Hello everyone, in this video I'm going to go through the AQA Combined Science Physics Paper 1 higher tier. This is from the 2022 Paper 1 higher tier in AQA. This paper is 1 hour 15 minutes and it's a total of 6 questions. And question number 1 is on energy, question number 2 is on the electricity topic, question 3 is on energy again. Question 4, particle model of matter. Question 5, electricity. And question number 6 is on the atomic structure. Remember, there's 4 main topics that you will be tested in paper 1 in AQA. Let's have a look at question number 1. So question number 1 is a graph. Figure 1 shows some of the energy resources used to meet the demand for electrical power in the UK on one day in 2020. So according to the graph, we have time of day at the bottom and coal is right on the bottom over here, and then wind, nuclear, gas, and the total demand, which is basically all of these added up, is the total demand. So 1.1, the maximum demand for electrical power on the day was at 6 p.m. So according to the question, the maximum power demand was at 6 p.m. Determine the percentage of the maximum demand for electrical power that was used generated using gas. So that's the key. So let's have a look at how much was generated from gas. So that's 15,000. So 0 to 5,000 is 10 boxes, which means each box is 500. So 15 plus 3 box, 15, that's 16,500. So let's mark these values. That is 16,500 gigawatts, and that is the total demand was 30,000. So what they want to know is how much is 16,500 as a percentage out of 30,000. So let's write the values here. The percentage would be 16,500 divided by 30,000 and then multiplied by 100 to give the answer as a percentage. So 16,500 divided by 30,000 and then multiply that by 100. That gives me 55%. Question 1.2. The UK government wants to reduce carbon emissions as much as possible. Which energy resources need to be used less to achieve this? Carbon emissions are caused from the burning of fossil fuels, so which is basically coal and gas. Nuclear and gas. Nuclear doesn't produce carbon dioxide. Wind is renewable, so it doesn't produce carbon dioxide. Wind again is renewable, so it will be coal and gas. Question 1.3. A network of transformers and transmission cables transfer electrical power from power stations to consumers. What is this network called? That would be the national grid. (1.4) Explain how using step-up transformers make the network efficient. Now remember, there are 2 types of transformers. I'll add a little bit of note at the bottom over here once I go through this. But there are 2 types of transformers: step-up transformers and step-down transformers. Right? You need to know about how they actually work, what the purpose is. So in this question, The reason we use step-up transformers is to actually increase the voltage. Step down reduces the voltage. The reason we are trying to increase the potential difference of voltage is so that we can reduce the current. Now, why would we want to reduce the current? Remember, the flow of electrons, which is current, is the main reason why conductors or wires have resistance. The higher the resistance, the higher the heating. And if the wires get hot, then you're losing energy. So the answer is the potential difference increases because of the step-up transformer. This causes the current to reduce. So there is less or low energy loss to the surroundings due to heating of the wires due to resistance. And that should give you the 3 marks. Now I'll add a little bit of note for this. So here's a little bit of notes on the national grid. This image shows the power plant where it's generating a potential difference of 12 kilovolts, and it's supplied to a step-up transformer which increases the voltage to 400 kilovolts in the high transmission cables, and then it's reduced to 13,000 kilovolts by a step-down transformer, and then it's step down again or reduced again to 240 volts so that it's safe for use by the consumers. So you have an initial step-up transformer and then step down as required. Now some industries might act like factories might require or be supplied potential difference at about 13,000 volts. 240 is for the UK houses. Now, what does a step up and a step down transformer look like? If you were to draw, in a step up transformer, the number of coils in the primary coil is less than in the secondary coil, whereas it's the opposite in a step down transformer. So the idea is to increase the potential difference here. So increase PD, increase the potential difference. Oops. And here, decrease the potential difference for the step down transformer. That brings us to the end of question number 1. I will see you in the next video.